All right. So we're going to start before, let me pause this recording. So in regards to digestive system, what I want to start with is that, well, your digestive processes are regulated by your autonomic nervous system. I mean, yeah, you eat voluntarily, obviously, but everything that happens in the digestive tract happens without your control, your conscious control, right? So basically, the entire set of digestive activities is governed by autonomic reflexes. And we need to kind of learn what is autonomic reflex. And remember, each reflex starts with some kind of a sensory input, some kind of a stimulus. And what kind of stimulus can we find in the digestive system? I can give you a hint. It's a word, 4 letters, starts with F. Digestive system starts with F. 4-letter, huh? Food. Yes, absolutely correct. So it all starts with food. That's your stimulus, right? Now, how our digestive system can appreciate food. So you obviously need some kind of a receptor, okay? Food is a chemical, so it can be chemoreceptor. Food can change concentration of certain ions. For instance, when you eat a drink, the concentration of acid in your stomach decreases, so that can be sensed by osmoreceptors. And obviously, if you eat food and it stretches your stomach or intestine, that would be mechanoreceptors. Virtually exhausts all our options in terms of the perception of food. Next, we have sensory nerves, right? Good. Sensory nerves, they deliver that signal that receptors receive. They deliver that signal to the CNS. Now, the key question, of course, which parts of the CNS? So, like, let me ask you this. If you eat something, can you consciously feel the stretch in your stomach? Kind of, right? Like, you know that some food is in there, right? But let me ask you this. Can you consciously feel the change of a chemical composition in your stomach? No, no. So we can basically exclude brain from consideration here, and the parts of the CNS that will control your digestive activities will be first and foremost brain stem, and to kind of a smaller level, spinal cord. Does that make sense? And then we have motor nerves. We have action that is exerted onto the effectors. Now, what are the effectors? What are the effectors of nervous system in general? I want to tell you. In general, 2 effectors of nervous system. Two effectors of nervous system. Yeah? Muscles and glands, right? Now, plenty of glands in the digestive system, of course. In regards to muscles, that will be, first and foremost, smooth muscles. So far, are you following? So let's take a look at this autonomic digestive reflex in general. Food stimulates receptors, generating a sensory signal. That sensory signal goes through the sensory nerves to the brainstem or spinal cord. There are some variations which we will discuss in a second. Brainstem generates a motor output, right? And that motor output is delivered by motor nerves to the effectors, glands or smooth muscles. Now let me ask you this. This motor nerve right here, is it somatic nerve or autonomic nerve? So these nerves right here, somatic or autonomic? Autonomic, yes, autonomic nerves. Remember, somatic nerves, they deliver the signal to skeletal muscles, voluntary activities. This will always be autonomic motor. Second question, remember in autonomic nervous system, there are two sub-branches, synthetic parts, right? Which one will be responsible for your digestion, for active digestion? Sympathetic or parts? No, parts, rest and digest. Now, this is in general your autonomic digestive reflex. Now, there should be one question that you should be asking yourself right now. It cannot be all completely autonomic because, you consciously appreciate the food. When I drink coffee, I know that it's coffee. I like coffee, okay? I can feel the taste. I can sense the smell, all of it, right? The texture and the texture. So it cannot be that our our brain does not participate in the digestion. You would be absolutely right. So things like we call it external stimuli, essentially sight, smell, taste, texture, even thought of food will stimulate your brain. Can you think of a food that you hate? Can you think of a food right now that you really love? Your digestive responses, two of them, will be completely different. Does that make sense? Up to a certain moment in my life, I was choking when I thought of one particular food. It was so unpleasant. So your brain will kind of govern your digestive responses, but it will not control your stomach or intestine directly. It will perceive the taste, sight, smell, whatever, and then send the signal to the brainstem. Does that make sense? And from the brainstem, you will have increased digestive activity in the stomach, increased salivation, and so on and so forth. Good? That clear? So, and I want, understand the difference between external and internal stimuli. So internal stimuli, food in your stomach, stretch of the stomach, stretch of the intestine, that's all internal stimuli. Sight, smell, taste, external stimuli that move from there. Got it? Another little problem, not a little problem, but we have a pretty long intestine, okay? And if you have to establish a communication, say you have food in small intestine, then it moves through all the duodenum, jejunum, and ileum, all the way to colon, and it goes through those meters and meters of intestine. And what? You have to communicate every time to the CNS and then back. That would be a lot of communication. There are certain activities, very simple activities, that can be local. So it turns out our alimentary canal, if you say a few words about it, alimentary canal, has what's called in Dutch enteric nervous system. Okay. ENS, enteric nervous system or gut brain. So what it means, you have neurons in the wall of a gut, for instance, that will not. So this sensory signal will not go to the brain stem. it will stay local. That enteric nervous system will produce some responses through those motor nerves on the effectors. Does that make sense? Think of it as a local chapter of a bigger corporation. Does that make sense? You understand what I'm talking about? So this is your headquarters. Anyone who works at not healthcare, some local business, anyone? So if it's not a secret. Huh? Okay. If you need to solve some problem at the store, would you call headquarters? No. Like small problem. No, you have a manager. This is your headquarters. This is your local manager. Does that make sense? There are certain things that you have to have brainstem involved. But especially in the gut, local plexuses will be just fine. Mostly the mechanical stuff, the utility, the movement. That make sense? More or less, we're good with this outline? Learn these outlines. On the exam, do not hesitate to draw these things out. That will help you. You haven't drawn out, you can just look at this and say, I find the answer to this question here, to this question there. Now, digestive activities. This classification is artificial as any other classification. So I prefer to divide them into the chemical and mechanical. Okay, so what chemical digestive activities we can identify in the alimentary food? Generally secretion and absorption. So far, we're good? Now, examples of secretion. Mucus, saliva, gastric juice, pancreatic juice, bile. Okay? All of it are secretions. Probably is not a complete list, but gives you a pretty good appreciation, right? And absorption, well, it's just absorption of nutrients, usually in the intestine. Good so far? Now, mechanical activities are, I think, much cooler. So why I think it is relatively easy to understand various digestive activities, because you have only one stimulus, which is food, or lack of presence or lack of. Does that make sense? And you know this stuff, like you eat every day. You understand what's going on. So for instance, what's the first activity that you do when you put food in your mouth? You choose mastication. Okay. Once you chew it, what do you do? So deglutition. Okay. And then once the food is in your stomach and then in your gut, you have to propel. It's double T. Deglute. Okay. Once you have the food in your stomach or gut, you have to propel, right? That's going to be peristalsis. I'm going to call it peristalsis. And peristalsis can be further kind of broken down into two activities. It's propulsion and segmentation. Now, what's the propulsion and what's the segmentation? Segmentation. It's a little bit different in the PowerPoint, not in terms of the sets, but like just outline. Now, the best illustration for propulsion when you squeeze the toothpaste out of the tube. Does that make sense? Good. The best illustration for segmentation, really don't have a good illustration, but think of it this way. You have an intestine, okay, a tube, and some food in there. And you start to contract intestine here, then here, then here, then here. See what I'm saying? So you start to mix things inside of the intestine by segmenting the food, by forming artificial compartments. Does that make sense? Okay. Well, there's probably we should include one more. Defecation. It is an activity, mechanical activity. That would give you a pretty good lineup of what's going on, and we're going to discuss some of that stuff. There we're going to talk about salivation reflex and deglutition reflex. Before we go on to discuss some activities, and we're gonna talk about your alimentary canal. We're gonna start at the mouth and just move on all the way to ends. Make sense? But before we do that, let's outline the importance of alimentary canal, which we call primary digestive organs. So what you have there is the mouth, which is primary digestive organs form that canal. It's mouth. What happens? What food goes up to the mouth? Not before supper. Massage it. Throat, pharynx, so mouth, pharynx, then esophagus. From esophagus, it gets into stomach. From the stomach, it gets into the intestines. We have small and then large. And small intestines, duodenum, jejunum, ileum, and large intestine we have cecum, ascending colon, transverse colon, descending colon, sigmoid colon. Then we have rectum and anus. As I mentioned before, anatomy is on you. It's memorization. You can do it without much of that. Deal? Anatomy is on you. What's the secondary digestive organs? They do not form a canal, but they secrete something or assist somehow to digestion. For instance, well, salivary glands, right? Secondary digestive organs secreting the oral cavity. People often ask tone, secondary digestive organ. It's kind of a part of a canal, but we consider it not a part of a canal, so secondary. Okay. Pancreas, liver, and gallbladder. That is it. Okay. Pancreas, liver, gallbladder all release the products, let's put it this way, into small intestine. So far, we good? Okay. So we got the alimentary canal outline, up there. So we're going to start our conversation about digestive system from your mouth. Couple of anatomical things. First of all, the study guide, anatomy study guide, is written with the purpose. I can ask you things on the anatomy study guide, but I cannot ask you things that are not in the study. That makes sense? So don't be surprised if things pop up on the anatomy exam that are on the anatomy study. I gave you rules. Anatomy is on you, okay? Unless it's something like massively super mega important. A concept that often is confusing. Difference between like oral cavity that we talk about and the proper oral cavity. So your mouth is divided into two cavities. Oral cavity proper is behind your teeth. So if you close your mouth right now, the place where your tongue is, that's an oral cavity. The space between your cheeks and lips and the teeth. You see what I'm saying? Where, for instance, people that chew tobacco, that's where tobacco is going. That's called buccal cavity, from bucca, cheeks. Okay? Does that make sense to you? Awesome. Now, let's get the teeth out of the equation. Deciduous, permanent, 20, 32, incisors, canines, molars. Incisors, canines, molars, molars. So the group that is not present among deciduous teeth is premolars. It is your responsibility to know the anatomy of the teeth. I showed you the picture. All the pictures that are going to be on the exam are in the PowerPoint. No exceptions. You're not going to see anything new, anything that you haven't seen before. Am I clear? Good. Structure of a tooth. Just to clarify some things, we've got several layers here. You've got outer enamel, hardest material in the human body. Then we've got dentin, kind of a bone, and here it's a pulp cavity filled with a connective tissue, and there are blood vessels and nerves in that cavity. So you have caries. The hole spans all the way through into a pulp cavity. Different crap goes in there, bacteria go there, inflammation, it hurts like hell. This is what dentists call a root canal. They have to clean out everything, blood vessels, nerves, and everything, in order to remove that inflammation. Does that make sense? Tooth is attached by periodontal ligament to the alveolar processes in your maxilla or mandible, depending on which jaw we're talking. Yes. It's attached to the alveolar processes in the jaw by so-called periodontal ligament. So technically, this is a jaw or post. Okay, so 32 joints. No, if you have all the teeth. Very good. Now, masticate, you chew. Now, salivary glands. Let's talk about salivary reflex. So what's the stimulus for salivation? Food, yeah, absolutely. Just keep going, food. Now, Manish is absolutely right. It can be, you don't have to put the food in your mouth yet, right? If it's there, absolutely going to salivate. But sometimes you see it, sometimes you think about it, and you start salivating, right? So either external or internal stimuli. Now, internal will be like just presence of food in your mouth, okay? So that goes through sensory nerves. Anyone remembers which facial nerve is, which cranial nerve is responsible, two cranial nerves that are responsible for taste? Long time ago. No, vagus will control your internal, specifically for transmission of the taste, the brain, so the brain and brain. Facial and glossopharyngeal. And trigeminal nerve will be responsible for the texture, like the touch, because your food touches your tongue and your cheeks, right? So those nerves will deliver the signal to the brain stem. Specifically, we're going to say specifically medulla oblongata. And then medulla oblongata through the motor nerves. Now, each motor nerve controls salivary gland. Facial and glossopharyngeal, two motor nerves. The motor nerves in the salivary gland. That makes sense. So that's another autonomic reflex. Because can you control your salivation? No. Not a trivial, it's not complicated, but it's not a trivial question. All the fluids that are produced in your body, like saliva, urine, cerebrospinal fluid, anything, what is the ultimate source of fluid component? Yeah, but like when saliva is produced by your salivary glands, where do salivary glands take this water from? Blood. It's all, basically, all your fluids is an example of a filtered blood. Does that make sense? You take blood, filter some shit out, leave some shit in, that's your saliva. Depending on which shit you're going to filter out, it can be saliva, it can be urine, it can be CSF, whatever you want. Make sense? Now, this, remember, can you remind me which component of autonomic nervous system controls digestion? Sympathetic or parasympathetic? Parasympathetic. So that's your parasympathetic reflex. When you rest and digest, this reflex is actively going on, right? Make sense? What happens to your mouth when you are really nervous? Like you have to give a speech. It gets dry. Why? Because you have sympathetic activation. That makes sense? Sympathetic activation inhibits this reflex, and not just inhibits reflex. Sympathetic activation will constrict the blood vessels where salivary glands get the water from. Make sense? You understand what I'm saying? Blood vessels that get to salivary glands will get constricted, less water, less saliva. Less saliva, dry mouth. Okay? Now, what are the main components of saliva? Obviously, water. I put sodium chloride electrolytes. It's mostly water, 99% water. Mucin. Mucin is a sticky protein that allows you to form a bolus of food. You know, if you eat something like a bread and you chew on it for a while, you get it out, it is sticky, right? You can make like a little bowl. When I was a kid, it was a bait for fishing. Okay. Lysozyme, the antibacterial protein, and immunoglobulin A, which is another antibacterial protein. That makes sense? Now, look, if somebody loses salivary glands, look what happens. Normal mucin, meaning that if you chew on the food, it's not going to stick together. Particles with particles not going to stick together. That makes sense? Normal lysozyme or immunoglobulin A, so bacteria will go rampant in the mouth. Caries is awful in those forms. Okay? and no more water. So you cannot dilute your food chemicals. You basically lose the sense of taste. And people do lose their salivary glands, for instance, when there's a tumor and the gland is to be removed. Make sense? Got it? Now, salivary glands also produce, there are two types of salivary glands. Intrinsic and extrinsic. Now, intrinsic are unicellular glands that are located in your tongue and your lips and your cheeks. Right? While extrinsic glands are big ones, multicellular glands. There are three of them: parotid gland, submandibular, and sublingual. Submandibular under the jaw, sublingual under the tongue. Anatomically, you need to know where they are. Now, what's important about saliva? So intrinsic salivary glands, they produce an enzyme called linguolipase. Lipase breaks down lipids. Good? Extrinsic salivary glands produce an enzyme called amylase, which breaks down carbohydrates. You follow me? So essentially, digestion of carbohydrates and lipids starts in your mouth. So far, we good? Following? Yes. Medulla oblongata. To make it easier, virtually all digestive activities are controlled by medulla oblongata. I mean, it's like everything from swallowing to vomiting. Okay? Questions about enzyme? If you want to prove that your saliva contains amylase, the enzyme that breaks down carbs, next time you eat bread, chew on it for a while. Keep it in your mouth for a long time. It will start feeling sweet taste. Amylase will break down starch to glucose, and glucose will start giving sweetness. Make sense? Okay. You've got salivary glands. Excellent. So we're going to go over one more reflex, and then we're going to chat about general structural alimentary. And our role I want to do is so swallowing reflex. Okay, now this one, it's one of the, in terms of the steps, it's one of the kind of longest reflexes with many steps. So bear with me and please tell me what you do when you swallow food. So it all starts with the food. Food is already in your mouth, right? So it's kind of formed nice balls. We often use the term balls of food. Now, first question. The start of swallowing, is it voluntary action? Yeah, you don't have to, you can spit it out, right? So you use your tongue to push the food back into the pharynx. Does that make sense? Now, a little side note. So pharynx. We have nasopharynx, oropharynx, and laryngopharynx. Does that make sense? Briefly, I'm not going to draw the anatomy, but to give you an idea. Nasal pharynx. Anyone got tested for coronavirus? The brain biopsy, right? This is nasopharyngeal swab. So they stick the swab into your nasopharynx. Nasopharynx is only respiratory, okay? So it's all the way up there. There's no food normally coming from nasopharynx. So it will have pseudo-stratified laminar epithelium. Now, when you swallow food, it goes through oropharynx and laryngopharynx. A lot of rubbing force. Does that make sense? A lot of abrasion. So here, you need stratified squamous epithelium. What kind of epithelium do you think you have in your mouth? Stratified squamous. Because of all those rubbing forces. Yes. Laryngo. Because it basically abuts larynx, your start of your respiratory tract. We good so far? The food goes into the oropharynx. Your oropharynx gets stretched because food is in there. That makes sense? So mechanoreceptors. Just gonna write down mechanoreceptors. Bless you. Now, signal from mechanoreceptors reaches medulla oblongata. Does that make sense? And that leads to several outcomes. First outcome, uvula closes nasal pharynx. You know that little, if you open your mouth and you look into the mirror, there's a little dangling thing in the back of your mouth, right before the throat. That's uvula. It lifts up and closes your nasopharynx. So when food is pushed by pharyngeal muscles contract and they push the food down. Does that make sense? Uvula just doesn't let the food to go on. Now, the best evidence for the fact that humans were not created is the absolutely stupid construction of our digestive and respiratory system. We have one pipe that splits in two. One is esophagus, another one is a trachea, right? It's ridiculous. We have same opening, basically, for food and for air. Stupid. But we have a way to get around it. Because the epiglottis closes trachea. So you're not aspirating. Does that make sense? Now, pharyngeal muscles, when they push the food down, since trachea is closed, where does the food go? From pharynx. Esophagus, right. The thing is, esophagus, when it's empty, it's collapsed. So we need to open it a little bit, right? So another effect we can put it right here is that upper esophageal sphincter opens. Does that make sense or not? So, upper esophageal sphincter opens, right? Food enters his esophagus. Now, you know what? I'm gonna show it on myself because I think I may not be as well skinned as this fella right there. But still, you know, I can kind of demonstrate it on myself. Okay? I'm not gonna move my mouth. Food gets in the mouth, I chew on it, right? It forms a nice ball. Then I use my tongue to push it back into my throat. Make sense? In response to food being in the throat, like throat stretches, mechanoreceptors in the throat sense it and send the signal to medulla oblongata. Medulla oblongata responds by closing my nasal pharynx by lifting urine, closing my trachea by pushing down on epiglottis. Make sense? So now nasal cavity is blocked, trachea is blocked. The only way for the food to go is esophagus. But we need to relax the sphincter. So sphincter relaxes, and then food enters the esophagus. That make sense? Clear? Know the steps. Know the steps. There is a good reason why I describe it. I'm going to be asking about this. Are we clear? The digestive reflex. Good? Not the digestive, the deglutition. And there is way more. So Ashley mentioned vagus nerve. Vagus and glossopharyngeal nerves become absolutely instrumental here. Because remember, they both are kind of responsible for gag reflex. So yeah, if this stuff is damaged, swallowing becomes problematic. We're good? Now, we're going to talk about esophagus kind of next time. In the last few minutes, I wanted to talk about the layers of alimentary canal wall. So starting at esophagus, the wall of alimentary canal is kind of similar between different organs. There are small differences, which we will address, but in general, there are 4 layers. So the top layer, well, do you understand the word lumen? L-U-M-E-N, lumen. Totally fine. When I was kind of, since I'm bilingual, me also, what is lumen? This is a pipe. The stuff inside the pipe, I mean, nothing. That empty space inside the pipe is a lumen. Does that make sense? What's inside, nothingness inside of the tube is a lumen of a tube. So this is why I say lumen of the intestine, that space inside of the intestine. Got it? So if this is lumen. The first layer right here will be some kind of epithelium. Okay. Then you have connective tissue. It's called lamina propria. And then you have a layer of smooth muscle. We can call it, that's the official term, muscularis mucosa. Okay? And this part right here, this is mucosal layer. You following me? We're good? Mucosal layer. Then we have submucosal layer. I mean, it's going to be just a bunch of connective tissue. We're good? You can ask what's there. Glands, blood vessels, this enteric nervous system, a lot of nerves there. Does that make sense? You with me so far? And then we have a layer, 2 layers of the smooth muscle. Oh shit, sorry. So we have circular smooth muscle and longitudinal smooth muscle. So circular, longitudinal. Look at my hands. So this is circular smooth muscle. When it contracts, what happens to the tube? Huh? Yeah, like this, right? So that's what circular smooth muscle does. Because it encircles the canal. Does that make sense? This is longitudinal. When it contracts, what happens to the tube? It becomes short. Make sense? So it's like you're pulling the soap on something. Combination of contraction of a circular layer and combination of and contraction of a longitudinal layer produces peristaltic motion. You see what I'm saying? It allows you to propel the food through the alimentary tract. We good? Clear? Okay, awesome. There are some exceptions. For instance, with esophagus, it's going to be a little bit different, not by much, but a little bit different. And then finally, on the outside, it's a layer of connective tissue with some simple squamous epithelium. This is serosa. Now this red layer is called muscularis externa. So again, mucosal layer, which consists of epithelium, lamina and muscularis mucosae. Submucosal layer. Muscularis externa with the circular and longitudinal layer. And serosa, which is the connective tissue that protects an organ and prevents it from rubbing against other organs. Does that make sense? As we will go through the different parts of alimentary tract, starting with esophagus, you will see that there are some minor differences. For instance, stomach has 3 layers of muscle in muscularis externa. Esophagus does not have serosa, it has a tissue. But we'll get that. Okay? Trying to think about some problem that I wanted to do. But again, I want to reiterate. This anatomy is important, but this physiology is, so to say, important. Okay, because this, it's a memorization stuff. These things are really hard to memorize. And one of the best strategies to learn this and to make sure that you got it, I'm going to put it in the tapes. Study guides. Look, you may have a thought, oh, blah, blah, blah. He says so because he made this study. It was really a learning process for me to figure out what is the best study that will help students to learn. I'm not saying it's easy, but it's the best. And so far, they work pretty well. And I had quite a few students that told me, fill out the study guide maybe more than once. They fill it out completely, and then print another copy and fill it out again. That makes sense? And yeah, that helps. That helps a lot. quizzes give you the idea of what kind of questions you can expect. But on top of that, something, and I understand, this quoted thing, we don't do study groups anymore. But quite frankly, nothing prevents you from exchanging emails and doing a WebEx study. And if you can explain a concept to your partner, you understand the concept better. Not only your partner understands it better, you start understanding it better. Does that make sense? This explaining really invaluable. If you want, you can find someone, explain it to a dog in your house. You're not going to get it. Make sense? So yeah, it helps. And this is why I focus so much on this process. You should be able to explain it, to understand it. Okay. Say it on that.